Hello everyone. In this video, we are going to explore a new feature of LuBan. It is called Flexi Cut. We open LuBan software and generate a simple 3D shape. I'm going to use a frustum as an example, and I will set it to have 10 sides. Then we go to Mesh Cut. In the list of the method, you will see a new method, Flexi Cut. The settings of the Flexi Cut and the planar cut are nearly the same. You can set the number of planes up to 10 planes, and you can adjust the parameters of each plane. You can optionally use a regional cut option to cut by a circular region. The only difference between the Flexi Cut and the planar cut is that in the connector section, the Flexi Cut has only one setting, tolerance, whereas the planar cut has several settings for you to configure the shape of the connector. The shape of the Flexi Cut is hard-coded in the program. You can use the cursor to adjust the position of the cutting plane, but you can't use the cursor to adjust direction. In order to adjust direction, you have to use the text input or the slider. I'm going to do a simple Flexi Cut with the default tolerance. I'll put the export folder on the desktop. This is what we get. You will see that there is a gap between the two, and the distance of the gap is twice the tolerance value. Now we use the highlight tool, select keyboard shortcut J to view inside of the two objects. This is part 1, and let's highlight part 2. As you can see, a connector that expands at the end is generated. So these two parts, if printed separately, cannot be assembled. The distinctive difference of the Flexi Cut method from all the rest of the cutting method is that you have to print the whole object in one go. You do not print each part separately. When you print the whole object in one go and find some way to remove the support material, and in some circumstances the support material is not needed, you will have the two parts interlocked with each other. We can also use the keyboard shortcut E to expand to see the shape of the connector. Now let's take a look at another example. I'm going to use a model of a duck to apply more than one cutting. In this case, I will use a regional cut. My first cut will be around the neck region. I'll make it a little bit bigger. So the R, I'll make it 0.6. Just about right. Then I'll use a second cutting plane to cut off the tail. Set this to 2. And then I will adjust plane 2. For plane 2, I will also use regional cut. And I'll cut around the tail. We have to adjust the orientation of the plane. Like this. To make it roughly perpendicular to the shape of the tail. maybe something like this. Okay, then we will set the tolerance to -1. I will use a big tolerance, and then click the cut button. Save it on the desktop. As you can see, the gap between the objects is very big. It is 2 millimeters. So 1 millimeter tolerance on top and 1 millimeter on bottom, similar for the tail. And when we press J to look at the connector, you will see that the connector looks like this. Maybe -1 is a little bit too big, but bigger tolerance gives you more flexibility. It is more flexible. You can rotate the head and the tail with respect to the body. You may ask that to print this whole thing in one body, it is not quite feasible because you have to use support material, for example, below the head. And you are exactly right. The flexi cut method may not be suitable for objects like this. It is more suitable for objects that look like a snake or a dragon. For instance, you have a snake or a dragon model that is flat on bed, then this is an exactly suitable object to be processed by mesh cut. I'm going to cut the snake into 10 to 11 sections, and preparing the cutting plan takes a little time. So I'm going to use a saved project. Go to the project FID file to load the model as well as all the cutting settings in one go, so that I don't have to do cutting plan preparation. In this project, I have used 10 planes, and all of the planes applies regional cut, and the tolerance is 0.3 millimeter. We have to check on the model size. The model size is pretty big. Here it is 40 millimeter in the Z direction. As a matter of fact, the snake model, the original snake model, is small. The original snake model looks like this. And if you check mesh statistics, you will see that the snake model the original one has a Z dimension of 7 millimeter. If I change it to a value close to the original size, you will see the size matters. Let's do a cut. The snake model is pretty big, so it takes a little while to process the model. Still processing. Wait, still processing. As long as LuBan does not close itself, it is processing, and it will come back. What I wanted to show you with the original size is that when the size is small, the connectors may not be generated. The original size of the snake model is 7 millimeter in height in Z direction. It is too small for the connector to be generated. And you see many parts without the connector. Actually, they have the connector, but the connector is so deformed that it doesn't function as a connector anymore. If you look at the original STL file, if you look at the cutted STL file, there is a thin plane of connector attached to the end surface of the section, but they are too small. So when you use the Flexi cut method, you have to check the model size in order to make sure that it is reasonably big. The expansion of the connector is about 2 mm on both sides in order to have a locking mechanism. So if the cut section is too small, no feasible connectors will be generated. Let's set it to 40. And we will do another cut. Again, it will take quite a while. Maybe I shouldn't do that. Let me stop the program from continuing. Delete. Instead, I will just open the previous results that I have saved on my folder. These are the proper connectors generated. Okay. And when we open the part files, we can see the connector. The connectors are expanded at the end section. So all the STL, so all the sections are interlocked. 3, 4, 5, 6, 7, 11 sections. Last but not the least, you have to use the all-in-one file to print a Flexi cut objects. If you print the part files, they will not be able to assemble because connectors are meant to interlock. That is all for this video. Thank you for your attention.